Okay, this example is called Can You Stop Your Car in Time to Save the Cat? You have a reaction time of 0.50 seconds and the maximum deceleration of your car is 6.0 meters per second squared. You are driving at 20 meters per second when suddenly you see a cat in the road 50 meters in front of you. Can you stop the car in time to avoid hitting the cat? Okay, so there's the road, there's your car, there's the cat, and there's you. So I think there's going to be, you're going to drive along for a little while before you hit the brakes. That's where you hit the brakes, and then the question is how far do you go after that? So, and it's 50 meters from you to the cat. So there's going to be two segments of the motion. The first segment, segment 1, will be constant velocity of this 20 meters per second. And its time is your reaction time, half a second. So we'll write it up there. Then you slow down at negative 6 meters per second squared. So segment 2 is the slowing down. So that's, and there's the acceleration. That's the basic idea. So here's these equations of constant acceleration, and I'm going to add a fifth equation, which is that if a equals 0, then your final velocity equals your initial velocity, and they both equal this x minus x sub 0 over t. So segment 1 is constant velocity. Acceleration is 0. So we're going to use that equation, and we're going to call it x1 is your distance divided by t. We'll call it t1 actually. t1 is 0.5 seconds. We're going to solve it out for x1 is v times t1. V, remember, is 20 meters per second. So x1 is just 20 times 0.5. That's 10 meters. That's how far you travel before you hit the brakes. Segment 2 will be your slowing down. So let's make a list of the knowns. So you know that you start off with 20 meters per second. You end at when you stop the car. Stops at the end. And your acceleration is the minus 6 meters per second squared. And the unknown here is how far you go, x minus x sub 0. We'll call that x2. And the thing that we don't care about is how long it takes you to stop. It's just whether or not you hit the cat. So looking at these equations, does not contain t is equation 4. So let's use equation 4. V squared is v0 squared plus 2ax minus x sub 0. We'll call that x minus x sub 0 x2. And v final is 0. So then we'll solve this out for x2. So 2ax2 is equal to negative v0 squared. Then I can divide both sides by 2a. Oops, I forgot the negative sign there. So negative v0 squared. So it's negative 20 squared divided by 2 times negative 6. So those negatives end up canceling anyways. And you get 33.33 meters. That's your second distance when you're slowing down. Total distance is d equals x1 plus x2. And that's 10 meters plus 33.3 meters. That's 43.3 meters. So that's how far you travel before you stop. This is less than 50 meters, the distance to the cat. So the answer is yes. You can stop the car in time to avoid hitting the cat. Yay, so that's a good thing for the cat.